finding the area of this compound shape. So why is it called a compound shape? It's called a compound shape because it's made up of smaller shapes which have been put together to make one big shape. So in this particular case, you can see pretty clearly really that it's kind of like two rectangles joined together. So this is a compound shape and we have to find the area. Now one more concept before we go too far. Because we are dealing with rectangles, don't forget that the area formulae for the area of rectangles is area equals length times width. Okay, so we'll be using that as well. Let's get on with it. There are two methods. One method that we will look at is called, well, it's not called anything specific. I'm going to call it the divide and conquer method. So in this way, we break up or divide the compound shape into its smaller parts, into the rectangles in this case that make up the larger one, the larger compound shape. So for example, we've got this particular rectangle right here, and we also have this particular rectangle right here. And if we find the area of this one, let me just get rid of that, sorry. If we find the area of this one and add it to the area of this one, we have the area of the whole compound shape. So that's what I mean by dividing. We're going to divide this whole shape into these smaller rectangles. So for this particular rectangle, let's try and find length and width. So I'm going to call this rectangle 1. So for rectangle 1, A equals length times width. And in this case, we have at right angles to each other, we've got a area equals a length of 16 and a width of 12. So 16 times 12. I'll use a calculator to give me the answer for this one. So I'm going to go with 16 times 12, and that's 192. So 192. So I know that this rectangle, this blue rectangle that I've outlined, it's got an area of 192 centimeters, and because it's area, it's got to be squared. Okay, so that's the correct answer for this one, but that's not finished, because remember, we also have this little orange rectangle. Now this orange one, unfortunately for us though, it isn't complete in terms of its dimensions. We know that in this case, this whole stretch from here to here is 20 centimeters. And we also know that from here to here, we're talking about 16 centimeters. However, this line is not 16 tall, but we know that from here to here, so in other words from here to here is 4. So 4 plus what equals 16? Well, we know that 4 plus 12 is 16. And so this length must be 12 centimeters. So 12 and 4 equals 16, and that's correct. Similar process here. The whole length is 20. I know that from here to here, it's 12. So 12 plus what will equal 20? So this little extra bit here must be 8. So that is obviously 8 centimeters. And now I have the information I need for rectangle number 2. So rectangle number 2, again, I use the formula area equals length times width. Second line of working is the length is 12, the width is 8, and hopefully we know that 12 times 8 is 96. What's the unit of measurement? It's 6, it's area. Unit of measurement centimeter, sorry. It's area, so it's squared. And now I know the area of rectangle number 2. All I need to do now is add up 192 plus 96, and that is 8, that's 18, and that's 2. So I know that the final answer is area equals 288 centimeters. It's area, got to be squared, squared. And that is the answer for that there. But there is another method that we can use, and just for ease of labeling it for something, I'm going to call this one method 2, taking a bite out of the whole. Okay, so this is how this one works, taking a bite out of the whole. So what I'm essentially saying to you is this. If we look at this compound shape, we can actually extend the main perimeter so that it makes a lovely rectangle, right? And that's what I'm referring to when I say the whole. And if you look carefully, you'll see that this part, this little rectangle here, has to be removed from the whole. And that's this taking a bite out of the whole. Okay, so I want to take a bite out of this big red bit. Okay, so here's what we're going to do. I'm going to have a look at this whole rectangle and get the dimensions for the whole rectangle. So what are the dimensions of the whole rectangle? So the length is here, isn't it? That's the length. So remember, I'm going to have to be using my area equals length times width, and I know that the length is 20. I just have to find the width. Now this 12 only refers to this. Remember, this is not even there. This is not there, and this is not there. We're going to take this out. So 90 degrees to this is 16. So we know that the area of the whole rectangle is a 20, that's 20, that's 20, that's 16, that's 16. So 20 by 16, and that's 320 centimeters squared. That's the whole rectangle. That's everything. Okay, however, remember, we need to take a bite. Oops, we need to take a bite out of that hole. And here is the bite right here. And we need to remove that, whatever that's worth, from 320. So let's go and do that now. So this is the bit that we're going to take out. We're going to take a bite out of the hole. And remember, the hole was this whole outline. So we're going to remove this blue rectangle, okay, because it's not there. So we just need to know what the dimensions of that rectangle are. So let's have a look at that, shall we? Area equals length times width. And for this little rectangle, we've got a length here of 8, and we've got a width, which was given to us, of 4. So 8 times 4 is 32 centimeters squared. So this little one, we now know what it is. It's 32 centimeters squared. Now that's not part of the hole. So we're going to take this bite out of the hole. So it's going to be 320, which was what the hole is, and we're going to subtract, take a bite out of it, of 32. Now you can do this by calculator or not. I'll do it manually. So 0, that can't work, so that you borrow. So that's 10 minus 2 is 8. 1 minus 3 you can't do, so you borrow, and that becomes an 8, and this here becomes a 2. And so we now know that the area is 288 centimeters squared.